Hi you guys, and welcome to today's lesson. We're going to talk about medians of triangles. To begin, we're going to talk about what is a midpoint. Remember, a midpoint is a point that divides a segment into two congruent parts. That's the first part of the warm-up. Next part is this: 1/3 of 9. Now remember, I can write 1/3 times 9. I can make 9 over 1. So 1 times 9 is 9, 3 times 1 is 3, and 9 divided by 3 is 3. Or you can do 1/3 times 9 over 1, and 3 goes into 9 3 times, and then 1 times 3 is 3. 1 times 1 is 1, and then 3 divided by 1 is 3. So let's try that for 2/3. Remember, in the math world, of is multiplication, so 2/3 of 12, so 2/3 times 12. 2 times 12 is 24. 3 times 1 is 3, and 24 divided by 3 is 8. Or we can do 2/3 times 12. 3 goes into 12 4 times, and 2 times 4 is 8. And then obviously half of 14 is 7. So let's get to those medians. A median is a segment joining a vertex of a triangle and that midpoint. That's why we talked about midpoints. Joins the vertex of a triangle and the midpoint of the opposite side. So here's my vertex, the corner of a triangle if you will, to the midpoint of the other side. That is a median. So from the vertex to the opposite side, it cuts that opposite side in half. I can try one from here to here, not straight line. And I can try one from here to here. Again, median from the vertex, corner of the triangle, to the opposite side, midpoint, cutting that opposite side in half. Now, there's a point called the centroid, which is where all three medians of a triangle meet together. So up above I drew one. Let's draw all three. So from the vertex to the midpoint, from the vertex to the midpoint, and then from the vertex to the midpoint. This point, big point right here, that is known as the centroid. That is where all three medians of a triangle intersect. Now there's a special little theorem that goes along with that centroid and that point of intersection. The medians intersect at the centroid, which we just talked about. It is a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. That's why we worked on some fraction work up above. Now, what that really means is this. If I look at the whole thing FC, that's a median. GC is 2/3 of FC, and FG is 1/3. Now notice, obviously GC is bigger than FG right here. GC, the bigger part of your median, is from the centroid to the vertex. So your bigger part is that, and your little part, your smaller part, is FG right there. That'll become important later on, because you're going to look for some lengths here. So if it says if FC is 15, what's GC and what's FG? Now, so GC is 2/3 of 15. So 3 goes into 5. 15 5 times, 2 times 5 is 10. And then FG is 1/3 of 15. 3 goes into 15 5 times, 1 times 5 is 5. Notice the relationship of 5 and 10. If I double 5, I get 10. Or if I take 10 and cut it in half, I get 5. That'll become important later, because a lot of the fraction work here is very confusing for some students. So let me help you with that. Here's the rules to help. If they give you the whole part, it should be the whole median here. If they give you the whole median, you take that median length and you divide it by 3 to get the small part. So I gave you the whole thing. FC is 21, so F21 divided by 3 is 7. So my small part here is 7. Then I double that to get the big part. 2 times 7, that's 14. Remember, the bigger part is from the centroid to the vertex. And if you notice, 7 plus 14 is 21, which is what we started with. Now that's if they give you the whole median, the whole thing. If they give you the big part from the centroid to the vertex, I take that length and divide it by 2 to get the smaller part. If you remember up above, that was the relationship. If I doubled 1 to get the bigger part, or I take the bigger part and divide by 2, so that's 5. So I know FG is going to be 5. And then FC, the whole thing, I just add these two parts together. 5 plus 10 is 15. And then if I'm given the smaller part, which is from the centroid to the side, if this is 4, I double the small part to get the big part, and then I know GC is 8, and then the whole median FC is 12. 4 plus 8 is 12. Those are your little shortcuts. So let's try those out. EB, so EB is the whole median, so I take my whole median, I divide it by 3. 30 divided by 3 is 10, so that's GB, that's my small part. And then I take my 10 and double it to get my bigger part. That's when I give you the whole median. What if I don't give you the whole median? What if I give you AG, which is the big part? That's 8. So I take my big part, cut it in half to get the little part, which is 4. And then 8 plus 4 is 12. That's the whole median. That was that setup. And then the third setup again is if I give you the small part, GF is 2. Double the small part to get the big part, so GC is 4, and then 2 plus 4 gives me 6 for my whole median. Let's try that again in another one. So EB is the whole thing, that's 36. 36 divided by 3 is 12. Double my 12 to get 24. New scenario. AG is 16, that's my big part. Take my big part, cut it in 2, that's 8. And then 8 plus 16 is 24. And then again, third scenario, GF, that's the little part, that's 5. Double it to get my big part. And then 5 plus 10 is 15 to get my whole median. So now it tells me again Q is the centroid, so I know those rules apply. DC is 48, so I gave you the whole thing. 48 divided by 3 is 16, and then double 16, that's 32. So DQ here is 16, and QC is 32. Same median, different information. I gave you QC, which is 20. That's my bigger part. Remember, from the centroid to the vertex. Cut that in half to get my small part, so that's 10. And then 10 plus 20 is 30 for my whole median. And then DQ again up there is 10. Again, same median, different information. I gave you DQ, which is 7, so that's that little part right there, 7. Double the little part to get my bigger part, 14. So QC is 14, and then add 7 plus 14 to get 21. And those are the shortcuts and little help for working with medians.